Hello everyone, we are at Beyond the Formula. Let's study distance of a point from a plane under three-dimensional geometry. So consider a plane here. Suppose this is a plane and we have a point, say P. We have a point and we need to find this perpendicular distance. Say this point is suppose M. So we need to find PM. PM. Right? So for this, let's understand, or first let's take the equation of plane as ax plus by plus cz plus d equals 0, right? Where a, b and c are what? Where a, b and c are direction ratios of normal vector. Okay, so we have n vector as ai cap plus bj cap plus ck cap. Okay, now to calculate pm, let's take a point q. We have coordinates of p as x1 comma y1 comma z1 and coordinates of q as x0 comma y0 comma z0. Now this point q, we have pq, qm and pm. We have pmq as right angle triangle, right? We have pmq as right angle triangle, or in vector form we have qp vector, pm or mp vector. Okay, so to calculate this distance pm, we can say pm is what? Pm is along n vector, right? As n vector is perpendicular to the plane and pm is also perpendicular to the plane, which implies that what? The pm, the perpendicular distance, should be along n vector, that is parallel to n vector. So if we say that pm is projection of qp vector along n vector, pm is qp vector's projection along or on n vector. So what do we see here? If we see through this, right, this view, if we see this view, so what we will see? Like this, we have p, we have m, we have q. If we take the projection here, this if we incident light here, we will see this pq projected over here, exactly same, and this will be what? This will be pm, this will be equal to pm. We have n vector here, and if I project this pq over n vector, if I project this pq over n vector, it will give me what? This pm, right? So what? Pm is nothing but the projection of qp vector along n vector, right? So let's calculate that projection. So we have this p, m and q. We have qp vector, we have n vector, and suppose this is the theta. This is the theta. So we have pm equals qp vector cos theta, qp vector's magnitude into cos theta, right? Now we can calculate cos theta. We can calculate cos theta using dot product. we can calculate cos theta using dot product. So we have Pm equals QP vector times. Now how do we write cos theta? We know that dot product between two vectors. So we have A vector dot B vector equals A vector magnitude times B vector magnitude times cos of theta, that is cosine of angle between them. So we have cos theta equals A vector dot B vector divided by vector A magnitude times vector B magnitude. So we have QP vector dot n vector divided by QP vector's magnitude times n vector's magnitude. So we have QP vector dot n vector divided by n vector's magnitude. Now writing it in Cartesian form. Now Cartesian form, what we will get? QP vector. Now what is QP vector? The position vector of P minus position vector of Q. So we will have x1 minus x0 I cap plus y1 minus y0 j cap plus z1 minus z0 k cap dot product with ax ai cap plus bj cap plus ck cap, right, divided by the n vectors magnitude, that is a square plus b square plus c square, right. So we have a times x1 minus a times x1 plus b times y1 plus c times z1 minus a times x0 plus b times y0 plus c times z0 divided by a square plus b square plus c square, right. Now see this ax0 plus b by 0 plus c z0, x0 comma y0 comma z0 was the point q lying on the plane, right, which means it will satisfy the equation of plane, right. See here, the point q lies on the plane. The point q lies on the plane, which will satisfy the equation of the plane, which is ax plus by plus cz, right. So as q lies on the plane, it satisfies equation of plane, right. So which will imply what? ax0 plus by0 plus cz0 plus d will be equals to 0, which implies what? That minus of ax0 plus b by 0 plus cz0 equals to d. So we will put this equation here. We will get final value of Pm as ax1 plus by1 plus cz1 plus d over a square plus b square plus c square, right. So this is the equation of, or this is the formula for distance or perpendicular distance of a point from a plane, correct. Thanks.